Everyone, August the 8th. Alright, let's continue the Java experience. Will be very fun. Actually, I'm thinking about even in parallel learning a new one. It'll be fun. I want to learn Rust. Alright, what is this? Given a zero-indexed integer array nums and integer p, find p pairs of indices of num such that the maximum difference amongst all the pairs is minimized. Also, ensure no index appears more than once amongst the p pairs. Okay, we've done this before. Find p pairs of indices so that the maximum difference among all the pairs is minimized. Also, ensure no index appears more than once among the p pairs. Note that for a pair of elements at the index I and j, the difference of this pair is absolute value. To the minimum, maximum difference, binary search. Min, max, usually binary search, among all p pairs. The maximum of an empty set to be 0. Hold on. The first pair is formed from indices 1 and 4. 2, 3, 4. The second pair is formed from indices 2 and 5. 1, 2, 3, 4, 5. The maximum difference is nums 1, 4 and 2, 5. So you want to find two pairs, or find p pairs, right? Find p pairs, and we want to make sure that the maximum difference amongst all the pairs is minimized. Okay. So let's sort it first. 1, 1, 2, 3, 7, 10. Now we want two pairs, right? I want two pairs such that their difference is the minimum, right? So the maximum difference among all the pairs is minimized. So in this one, I say I take these two, I take these two. And in this, we pick one pair, so yeah, definitely do this. So we're gonna take some pairs, right? And we want, after we take the pair, we want the maximum, the difference to be minimized, which means when we take all the pairs, we want the maximum difference between all the pairs to be small. So usually in this one we can do, binary search, right? So the max difference we have, the min difference can always be 0, and then we pick the mid difference, and then we just need to find, if we can find the pairs such that they are smaller than that. If they are, then we can do a little bit bigger. Okay. Then how do we check if we say we have a mid difference is the maximum? And how can we make sure that we have enough pairs to hit this value? So we sort it, and then what? Yeah, we want to make sure that there are enough pairs out there, right? And what do we do? Pairs. I want to find how many pairs will have the difference smaller or equal to this mid. Right, that's the one. We want to find the number of pairs whose difference is smaller or equal to this value. And we know adjacent ones always have the smallest. So yeah, the adjacent ones always have the smallest. But I know like the problem can be you cannot always take the adjacent because sometimes you might need to take it adjacent here, right? So man, you don't know. Right? That's the thing, you don't know. The maximum difference among all the pairs is minimized. How do I check the difference? How do I check if it's possible, right? They give you a mid difference. How do I know if there are enough pairs? Right, so we can pair them up. Right, we can pair them up. Let's say, I mean, the biggest one is 9. So I'd say the difference is 4. Can we find enough pairs such that their difference is always smaller than 4? I mean, maybe what I can do is for each one, like binary search it, like to do 4. We need a 5. But we don't have a 5, so I say I can take a 3. So this 1, I can take a 3. Right, and now this, I can take a 2. And it's already 2, so say 4 is possible. Now we have 2. Okay, the difference has to be 2. And it's also possible. Now the difference is 1. And 1 will take up to 2. And then it's not possible. So that's not right. That's not right. Or I mean, the smallest it has to be this, right? So maybe we can find the difference. Right, this is the difference. And if you want to take a pair, is it always better to take adjacent pairs? Because adjacent pairs are always going to be smaller. No, I think it's not going to be adjacent pairs all the times. Wait, how do we do this? I don't remember at all. I don't remember. Maybe it's not binary search. I feel it is binary search. Is this one of the difficult ones? I don't remember. No, I think I solved this one last time. I'm stuck. What the hell? I've done this before, probably like a month ago. I don't remember at all. We sort the nums. And how do we decide the number of pairs? I mean, I'm kind of intent just to sort it and just do this. Like, seriously. But it has to be adjacent, right? It has to be adjacent because there's no other way. So if we're talking about adjacent, so we do this. Or, I mean, you can always just slap one, so you do this. So you kind of get a kind of a feeling of how things are, and then decides how it's supposed to be. Because if it's not adjacent, okay, if we have an answer that's not adjacent, then we can always find a smaller difference by choosing adjacent. So the final answer has to be adjacent, right? So, but the question is that do we start from the start, or like somewhere along the way we have to do, like there's this mismatch. So, and we need P, right? We need P. So the problem is if I get these, like if I get this, then I cannot get this, right? Then I have to get the next one. So what do you say? Well, how about, I don't know, I mean, he's talking about finding all these adjacent values, get them out, and then look for the minimum among them. I mean, that doesn't seem right. Doesn't seem right. Yeah, I kind of remember, like, now that you mention, I kind of remember there are situations where you don't take the 0, but you take the other ones. How is that? I start to have memory of this, but the solution wise I still have no clue. We don't always take the smallest. Why? Because if we take the smallest, the next one may be big. If we don't take the smallest, yeah, something like this, right? If we take the smallest and then something like this, if we take the smallest, then nah, that's not. So now I was trying to say we have to take this and take this. I don't know. It's maybe like this. right? If we take the smallest, then we can only have 2, like this. If we don't take the smallest, we take this and this. Things like this, right? Things like this. And how do we decide? Maybe DP? Do you think about DP? To find a minimum, the maximum minimum from the start to the end. So for each one, what we can choose is I either do this, or I abandon this. I don't do it, and I do this. Does that work? DP? Is this going to be a DP? So we say DP index, give me the min max, right? Give me the min max. So for each, give me for each index, to find it, I can say I'll take this, right? And you give me the min max of the remaining. Or I don't use myself. I just return this. I don't know. You want to give it a shot? Feels very sketchy. Feels very sketchy. But it doesn't hurt to try. And then I will try this. So, DP. That's just feels strange. Anyway, we need a memo. We're gonna do int memo. Okay, and now we say private int DP index. Oh, that's Python. Index. No, just index. Right. This will, and also I need nums. Right. Int nums. Alright, so we can say if index go to the end, so then the value, right? What we want is the value. So if I go to the end, has no value. So I say if index equal to nums.length, I believe this returns 0, right? Oh, I remember. I will use integers. And then I say if memo index is not equal to no, return memo index. Otherwise, right? Otherwise, we can say int res equal to math.max integer.max value. Okay, then we can say two scenarios, right? One is I probably can just say memo index shall equal to math.minimum of the max value, right? Minimum of holy crap. If you have only one, what is that? Can do. So pretty much this one has to be abandoned, right? Yeah, so if I'm here, I can do this, or then there's nothing, right? And there's nothing, there's no more I can do, because if it's two values, you just have to take those two. I have to take those two. Oh, and also P. Don't forget the P. Oh, don't forget the P. That doesn't seem to be DP anymore, because you have to consider only take P. Wait, what the hell? We have to take P pairs. Right? P pairs. It's starting from this index with P pairs. That doesn't sound right. With P pairs. You can't do P pairs. No. No. Or maybe we can say, yeah, I cannot do DP directly. Or if we go back to binary search, so just given a difference, I want to know what's the maximum number of pairs I can find. Right? The max number of pairs I can find. Can I do that? Can I find the maximum number of pairs? Maximum of pairs. Yeah, I guess I can. I start from here and I say I want to find start from here the maximum number of pairs I can find with the current given difference. And I do this. Or I don't do this. Yeah, maybe I can do that. Maybe I can do that. Hold on. Maybe I can do that. Maybe I say this is to find. Wait, hold on. DPI is the max number of pairs. Oh, and max diff of pairs in nums that are smaller or equal to max diff. Can I do that? Then I can say if index is equal to that, right? Or I can say is larger or equal to this -1. Right? Because if you hit the last value, then also it's not possible. Then that's a 0. You don't have anything. Otherwise, return this. Otherwise, we want a maximum number of pairs. Right? Maximum of pairs. Hold on. I probably shouldn't do it this way. I probably should first say option 1. Alright? Do not consider the current. Do not consider the pair. Nums index. Nums index plus 1. Do not consider this pair. If I do not consider the pair, then that's going to be DP index plus 1 nums max diff. Right? Option 2, consider the current pair. Okay? Then we can say can I cast? Oh, I know what to do. I can do this. Java J shell. Yep. What I want to see is can I say int 2 larger than 0? Ugh. I wait, hold on, I cannot int a equals to 2 larger than 0. This won't work. Boolean cannot be converted to int. Dude, Boolean cannot be converted to int. I hate it. Alright, so we consider the current pair. Then we shall say memo index shall equal to math.maximum memo index, right? And then what? And then it shall be nums index minus nums index plus 1. And this I hope have ABS. Yes. So this, if it's smaller or equal to max diff, okay, then we'll add 1, right? Otherwise it's gonna be 0. So this whole thing plus dp index plus 2 nums max diff, right? And that makes sense. We have two options. Option 1 is we don't consider the current. We directly go for the remaining. Option 2 is we consider the current, and if it's smaller or equal to this, we can add 1 pair. Otherwise, it's 0 pair. And then we'll plus dp, we have to jump 2 forward, right? Because I take index plus 1, so we jump 2 forward to index plus 2, and then we do this. And I mean, I probably can just do this way. Yeah, I think it makes more sense. And we put this one inside. Right? We put this one, so this is option 1, and this is option 2. Okay, option 1, option 2. So I have 2 options, and then we'll return memo index. Does that make sense? If index is too large, if index, this is nums length minus 1. If you hit here, or you go beyond, that's always going to be 0. If you're here, then you can say this, then that will be 0, or you can take the current. So we'll do that. Okay, we'll do that. And we need to initialize. We can say memo equals to new integer nums dot length. Does that make sense? Yeah, I think it does make sense. Okay, and then what? And then we need the binary search. We can say int low is always going to be 0. Int high. Oh, we also have to sort. Oh, arrays dot sort nums in place, right? This sort is in place. Void, yes, it's in place. So high shall equal to nums there's no minus 1, nums dot length minus 1 minus nums 0, and always make it a little bit bigger. Okay, so I have low and high, then we say while low smaller than high, int mid equal to, oh, I can define int mid outside. I don't know, I mean, I guess let's define it inside. Low plus high divided by 2. Okay. Then we need to say, we call it dp, this dot dp. Or can I just call dp directly? Like I said, I can. Index is always starting from 0, right? With nums, and max diff is mid. So we can say int, or we can just say if this, the total number, right? The number of pairs that has the difference smaller or equal to the current, if this is larger or equal to p, that means we can make, that means the diff is too big, right? We have too many, right? We have too many, so we can get the diff a little bit smaller. Then high shall equal to mid, right? Else, that means we don't have enough, right? We don't have enough. We have less than p number of pairs that can satisfy. So in this case, we need to allow the difference to become a little bit bigger. Then we say low equals mid plus 1. So we do that, and eventually when we come out, right? So low equal to mid plus 1, right? So high is equal to mid when it is good. When it's good, we kind of shrink. When it's good, we kind of shrink. And at the end, and in the low, which is not good, so plus 1. So I think we just return low. All right. Are you ready? Honestly, no. But we'll take a look. Oh, examples. Oh my goodness. That was not right. Alright, we have to do this. Oh, that's gonna take a long time. Jeez. I absolutely don't like it. But alright, so we need to say int this nums is new int did it give me how do I set this? Do I set this way? Do I set it this way? 10 1 2 7 1 3. Oh my god, that's not even possible because these two has to be the same size, right? Holy crap. Holy crap. How am I supposed to do this one? Yeah, how am I supposed to do this one? It has to be a map. It has to be a hash map. Because these has to require them to be the same. I don't think I can do it this way. 4 2 1 2. Can you? It looks like it. No, I don't think so. Piece 2 1. Answer 1 0. Okay, so this is going to be min max nums is piece Does one compile? Oh man, this is right. You can't do it this way. Alright. We just need to figure out why it's not right in the first one. That's okay. We can figure it out. Let's comment this out and turn this into the first. All right. Oh, we can debug. Good. Good. We put it here, and debug. Oh my god, this is so fun. All right, where am I? Index is 4. Huh? Max diff is 5. What's this? Resume program. Max diff is 5. Memo. I want to see memo. So memo 3. Given the current max difference is 5. I mean, the max difference of 5 is always going to be good, right? 2, 1. So difference is 5. I shall have, hold a second, let's pull this one up. Difference is 5. The maximum I shall get 1 pair, oh no, hold on. 1 pair, 2 pair, 3 pairs, 4 pairs. I should get 4 pairs. Oh, you only got 3. Index 0, you only got 3 pairs. That's bonkers. Right? Nums is this, index is 0, max diff is this. Yeah, I think it's wrong. What I see is what's this return? It's 3. Starting from this 3. 1, 2, 3. 1, 2. Oh, it is 3. 1, 2, 3. It is 3. Okay. Let's resume. Oh. Then we're done. What? High equals mid. Mid is 5. It's bonkers. Can we do this again? Right? Max diff is 5. Yeah. How? Hold up. Right? High is 10, mid is 5. So high equals mid. Okay. So this mid is going to, mid is equal to 2. Right? Mid is equal to 2. So we shall find 1 pair, 2 pairs. Okay. So mammal. Oh shoot. You need to clear the mammal. I think I know. I should clear the mammal because 2 is only should be 2 pairs. How do I clear mammal? How do I clear don't worry. Java clear array. Empty an array. How do I empty an array? Okay, this says garbage collector can collect it. So I think what I would do is, okay, I can stop. I can take this. Okay. We'll do it every time we call DP. Before we call DP, we'll get a new. There we go. Now we pass. Right? Now we pass. Yep. There we go. Now we pass. So the key is to not do it here, but every time before do it here. Now we can pass. All right, I think we can write some stuff here. 2616. Use binary search to find the min max diff, and use DP to find the max number of pairs that can satisfy current diff, right? If the max number of pairs is larger or equal to P, we can shrink the diff even more. Otherwise, we have to increase the diff. That's O and log n. All right, last time, and we're gonna submit this. Hopefully it's right. Oh, you know what? Let's run some tests like this with one pair. Doesn't matter. Or doesn't matter. Or like something like this. 3 pairs. I don't know. Throw something in. P has to be valid from 0 to 0. Oh, it has to be this. Oh, jeez. So it has to be 0. Alright, looks good. Try it. Alright. 5%. My. That was poor. That was poor. I mean, we solved it, but it's very, very poor. What was the method? Dear me. Alright, so yeah, it's only like 2 months ago we solved this problem, but I forgot. Sorted array of diffs between JSON pairs. Pick a max diff, then binary search to find the range where all the diffs are smaller than max diff, if there can be at least p number of pairs. Isn't that what we're trying to do? We sort the diffs. I mean, that's basically the same idea, right? What else? pick a max diff. And we have sorted diffs, which is this. Okay. Oh, can we do this? I guess we can. List of indices for all pairs. Ah, I think I know. Yeah, you get the sorted diffs and then you come from start to end and you try to sorted diffs J and 1, which is the indices, right? If not used, check whether an index has been used before. Yep, then you append. There, yeah, that's one way to go. So what is this? Super fast. Nor do we have to do additional boundaries. So we simply sort nums and go from left to right and find the total number of pairs whose diff is smaller or equal to the current mid. Greedy is used here in that we always record the first pair that satisfies our requirement. It does not matter if picking the first pair would preclude us picking the immediate next pair. I remember that. Among these two pairs, we can only get one. Holy crap. Oh yeah, that makes sense. That makes sense. Alright, let's copy and paste this one first. Let's call it solution 1. And let's do a solution 2. So no DP. We don't need DP. Hey, but DP works, right? DP works. Oh, I shouldn't say ON login. It's not ON login. It's M log M. Wait, hold a second. Log M. ON log M. That's the one. OM log N. But oh, Java is so much faster. But we can do much better. Can do much better. No binary search. No, we still do binary. No need for DP. We can use greedy. Oh, I remember now that I read it, I remember it. We can use greedy for any triplet or any adjacent triplet in nums. We can only pick one pair, either A0 A1, right? Either A0 A1 or A1 A2, right? Thus, it doesn't matter which pair we pick. That is, picking the first pair would not cause the exclusion of the second pair. And so picking the first pair and thus excluding the second pair would not have any impact in the overall analysis. That's the thing. So we can sort, we do this, and we don't memo. We basically just int max pairs equals 0. Yeah. Thus, for any given diff, we simply go through nums and pick the first pair that and always pick the first pair that has diff smaller or equal to the given diff. Right, now we say for int I equal to 0, I smaller than nums.length minus 1, I plus plus. Oh, may I? Holy crap! Can I not do this? I think I can do this, right? And we just say if nums I plus 1 minus nums I is smaller than mid, smaller or equal to mid, then we say max pairs plus equal 1. And I plus equal 2. Else I plus equal 1. Then we can say if max pairs is large equal to p. Alright, does this one work? Yep. I think this one works. Then we avoid binary search. No, we still have to do binary search, but we avoid the DP. Oh my goodness. Oh my goodness. Oh my goodness. The amount of time, the speed boost is ridiculous. We're talking more than 10 times. Holy crap. The memory usage is also slower. Yeah, greedy can do wonders. Greedy can do wonders. Oh, I forgot to include we do have O n log n, which is this, and plus n log m, right? Where m is the max diff between, is a diff between the min and max. That's actually a better way to say it. Between the min and max of nums. But boy, is this fast. Well, DP works. My original solution also works, which involves more binary search. Okay, so this is solution 2, right? This is solution 2. Okay, this is solution number 2. All right, so we're done with this. Good question. Well, we don't have much time, but let's try this one. Let's see what this one's about. Maximum strength of a group. Zero index nums representing the score of students in an exam. Teacher would like to form one non-empty group of students with maximum strength, where the strength of a group of students of indices is defined as their multiplication. What the hell? Return the maximum strength of a group the teacher can create. So, ooh, non-empty group. 0, 2, 3, 4, 5. Huh. Okay. I mean, huh? Maximum, and they are all from -9 to 9. Well, if you want to pick the negatives, if you want to pick the negatives, you have to pick pairs. No, pick positive is also pairs. So for one, negatives and positive need to be separate. All right, I have a bunch of negatives, and I have a bunch of positives, and I don't think they impact each other. So, and it's gonna be multiplication of them, right? It doesn't really matter how many we pick. Okay, so we have a negative, we have a positive, and then we always want to multiply them together. So what we can do is, for the positive, you just multiply all the positive together, right? It doesn't really matter. You just multiply all the positive together. Yeah, we always multiply all the positives together. So the problem is about the negatives, because I don't see there could be any downsides. Multiply them positive together. I mean, we exclude 0 for sure. We don't want 0, right? And the positives, we just multiply all the positive together. It's always going to be good. You multiply. And then for the negatives, you multiply them together as well. Huh? What's the trick here? Like, seriously, what's the trick? I don't see the trick. I mean, for the negatives, if we have even numbers, we just multiply everybody. If we have odd numbers, we just multiply the smallest one, and then we leave 1. Did I miss something? I don't know. Did I miss something? I think because it's too suspicious, right? So basically what I'm saying is we're gonna do arrays.sort, right? After we sort the numbers, we're gonna say we're gonna multiply from left to right. If it's negative, we're just gonna we're gonna just multiply, and then if it's a 0, we're gonna skip. If it's a positive, we're just gonna multiply, right? Okay, so we can say interest equal to 1. And I mean, if it's all 0, then right? If it's all 0, can we do like in one pass, basically? That's what I'm thinking. Can we do one pass? Okay, I see. This is just... Okay, so how about this? We're gonna find out the number of negatives. Oof. We find the number of negatives, and then we find... How should I put this? How can I make this one? We can count, or we do this. How about this? We say arrays. We want int, but I don't know how many, right? So I have to say array list, right? Integer negs equal to new array list. Okay, then for int res equal to 1, for int n of nums, if n is smaller than 0, next dot add n elif then how do you know everything is 0 then? That's a good question. How do you know? So that's why I set it to -1. Right? We can say positive product. Else if n is larger than 0, pass this times equal to n. If it's 0, we skip. Right? Now, once we're done, we say if next.length, I think probably size, dot is empty. Oh, what if everything is empty? That's a good question. I actually don't know. What if everyone is negative? And what if we have this? I think everyone is negative. Oh, holy crap. That's not right. A group this and this. I think both should be 0. Oh, you can be negative. Holy guacamole. All right. All right, so if I don't have any negative, okay. If I don't have any negative, then, okay, we need to first make sure. So we have negative, we have 0, we have positive, right? If I don't have any negative, or I don't have any positive, then it should be 0. So if we don't have any negative, and it's still equal to -1, which means we don't have any positive, then we should return 0. No negative, no positive, then it's going to be 0. Right? Otherwise, we'll have some negative and some positive. Then we can try to calculate the maximum. Right? Then we can say positive equals minus pos. And wait, hold on. Because if positive is this, that means we don't have any positive. If we don't have any negative, right, then I think I can do this way. If I don't have any negative, then we have positive or we have 0. Then we say if positive is equal to -1, which means I don't have any positive, then we'll return 0. So we can say return, right? Is this equal to this? If it is, we'll return 0. No positive. Else, that means we have some positive and then we have 0. Then we return minus this. Okay? Else, we have negative. Okay? Now we have negative. Now we have negative, it depends. Right? It depends on if I still have positive or not. It doesn't matter. We just want to pick the maximum on negative, which means the maximum on the negative we can find out by doing next dot sort, right? Oh, I can't do that. Has to be, wait, array? Hold on. Nope, cannot sort this. Array list? Oh, I know. How do I sort array list? Collections.sort. Ah, gotcha. Right, so we sort the negatives, and then we can say if len, I can also do int neg product. Okay, so I can do if next dot size is equal to 1, right? Then neg product is actually equal to next 0 dot at get 0, else for int I equal to 0, I smaller than, or then depend on if it's even or odd. If it's even, we'll multiply all of them together. Oh man. Yeah, that's fine. I just do next dot size. We say neg prod times equal to negs dot get I. What's wrong with this? For loop can be replaced with the enhanced for. Oh yes. Yes. Right? And now we say if neg product is smaller than 0, then neg prod divided equal to negs.get 0. Okay, so this is me getting the negative product, right? Getting the negative product. Now what? So now I have the negative product, okay? Then we have well, 0. Maybe we should count if there's 0. And now we have a positive product. So we have negative product. Then we need to know if there is any zeros in it. If there is 0, we should do 0. If there's no 0, but how do I know if there is 0? So let's do this. Boolean has 0, false. Actually, I don't have to initialize those false as well. Else has 0 equal to true. Okay, so this is fine. If negative is nothing, then we do this. If we have, then we have this. Then we need to say if there is any, because positive actually is fine. Right? If nothing, we just set it to 1. It's okay. Then we shall do is, yeah, because if it's equal to 1, otherwise we can always get a positive value. Then what we shall do is return, right, math.maximum. I would say negative product times positive product. Okay, if we don't have 0, right? If we do not have 0, then yes, we have to multiply the two sides together. If we have 0, then it's gonna be, so it has to be, if we has 0, right, then the maximum of this and negative product times positive product times 0, basically just 0, right? We define the maximum of the two. If we don't have, then it has to be times positive product. Might not have been initialized. Okay, so they want me to initialize, so I'll do false. What's this problem? Implicitly cast too long. Can I cast it's too long? I don't know. How do I cast integer too long? Oh, it's a long thing. You know what? You don't have to cast. If you start with long, right? If I start with long, then, and when you start here with long, then I don't need to cast. And this is actually wrong to do the cast. The syntax must be right. Must be wrong. So is this right? Whatever the screwed up this is right? Ah. What the hell? The hell? Where did I go wrong? I have to consider the second one, right? Second one, this is not. So we sort this. So it's -4, -4, -5. No, -5, -4, -4. Dude. Can I sort reverse? There we go. Reverse order. Okay, now I try. Is this right? No. How? Oh, we only have one negative. Oh, yep. Yep. I think we missed one. This is definitely right, so we don't have to consider this anymore. So the one that's not right is here. Could be replaced with, okay. Blah, blah, blah. Maximum has 0 if we have 0. Then we try not to multiply 0. If it doesn't have 0. If we have 0, we can decide to not include 0, or actually we can say int max neg positive shall be max.max neg product times positive product or positive product. Right? If this is not int, it's gonna be long. If this is a negative, the negative times the positive, we choose this. Or what if there's no positive? Yeah, what if there's no positive? Oh man. So there's no negative. Then we have negative. Then we just say if there's no positive, if positive product is equal to -1, right? So this is a no positive. Yeah, this is no negative, and this is no positive. If we have no positive, then it has to be return has 0, then max.max negative product or 0. If we don't have 0, then it has to be negative product. End of the story. Now we have positive, so have has positive. So we get a positive up, so we can get the maximum of this. So we have a positive, either to take that, or we multiply it by the negative product. Doesn't matter, it could be negative or positive. And then we return this. All right. So it's going to be, and this gotta be a positive value. Yeah, because we have positive, so it definitely is not gonna be, it's not going to be. So I think I can return this directly. And how do I delete a line? Just delete a line. Right? So this is no negative. We do the positive thing. Yeah, and if no negative, no positive, they gotta be 0. If we have positive, we return positive. And we have negative, we get the maximum negative. Then we say if we don't have positive, then we have negative or 0. So if we do have a 0, then it's going to be the maximum return to 2. If we don't have 0, it has to be negative. Now if we have positive, right, then it's either negative times positive or the positive by itself. All right, I think this one shall be right. Come on. Yeah, I think there's a lot of conditions to go through. Oh my goodness. What is this condition that we didn't consider? Oh, God. I was trying to not to get a pause. Well, I guess that's not. Alright, so I'm biting a bullet. Positive count. Okay. Boolean has pause. Screw this. This is gonna be 1. Negative dot add, because we just sort it. Right? I mean, I don't even need to sort it. All I need is the minimum on a negative. You know what? I need to know the count of the negative. I need to know the count of negative. I need to know. Yeah, hold on. Positive product. Negative product. Has 0, has positive. Neg count. Okay. Then for this, then we say neg product times equal to n neg count plus equal 1 has pause equal to true. Right? Then when we're done, now we can do a series of if neg product, no, if negative count is larger than 1 and neg product is smaller than 0, then neg product divided equal to mass.min nums. Okay, so now I have the 3. Right, now we have the 3. Okay, so now it's just a series of conditions. If has positive. Okay, that's the easiest one. Then we will return mass.maximum positive product times negative product. Because if we don't have negative, then negative will remain 1, which is fine, or positive product. Done. Now if we don't have positive, right, then we can say if I have negative, I don't really have a negative. if net count is larger than 0, which means we have negative. Okay, we have negative. If we have negative, then oh shoot, that's probably another one. Arrays. How do I find a minimum in an array? Collections.min. You gotta be kidding me. Really? You gotta be kidding me. There's you gotta be kidding me. There's no built-in for array. So it has to be collections.min, but we cannot do nums. We can do nums, but we cannot do that. We can say arrays.asList. What's wrong with this? Remove braces. That's not a problem. What's this? Replace with list of. Add brace. What do you want me to do? I have no clue. Remove brace for. Why? Array utility dot. Arrays actually, but arrays dot. I tried arrays dot as list. It didn't work. It didn't work. No instance type T exists so that it conforms to. Oh, this is stupid. This is as stupid as it can be, man. You can't even do a simple min. My God, arrays utility. Array utility. Common line. You're kidding me. Stream. Okay, let's use a stream. What's this? Arrays. Dot stream nums dot get dot min get as int. Oh, this is bonkers. Okay, so go back to this. The negative, we get a negative. All right, if I has positive, we do this. If we have negative count, right? If we have negative, but we don't have positive, then we shall return the max, either negative this or 0. No, 0 is only possible if we have a 0. Right, so we say has 0. If we has 0, then it's going to be this. If we do not have 0, then it's just going to be this. Now this is if we don't have negative, we don't have positive, then we just return 0. Because you have to have 0. Okay, let's try this one. Yeah, it's not really hard. It's just so many conditions you have to consider. Now you can consider this as like what? I think it's the same problem. You're dividing the wrong thing. Are you kidding me? Oh, the maximum. My bad. Oh. I am not happy. Int max neg. Integer dot max value. I took a negative for this. If n smaller than this and max negative equal to math.max n and max neg. So now this I can simply divide it by max negative. If it's larger than 1, right? And if it's negative, that would divide by this. So you're happy now? Are you happy now? Okay, maybe we're happy. Yeah, it's not tough, but it's not difficult, but dear me. Okay, this is not difficult, but the amount of thinking into all the cases, all the possible cases, is quite demanding. Plus it's Java, so you have to add that to your ordeal. But I think that's it. I think that's it for today. 2708. What do people say? That's very simple, just a lot of edge cases. Yeah, I think it's the same idea. Yeah, there's nothing special with this. All right, that'll be it. An hour and a half. It just seems like when I start doing Java, it just takes longer. All right, I'll see you guys tomorrow. Adios.